Lizel is, Professor Lizel is from the University Stellenbosch, plant pathology. Ek sien Karen, jy weet jy so sit wat voor die dekaan was. Maybe it's not a printing error. 91 artikels, akademiese artikels. Is dit moontlik? 91 articles in peer review journals. I think this is absolutely brilliant. So vir enige iemand wat die dinamika verstaan van 'n departement of 'n fakulteit se finansies en this is a big asset. So thank you so much, Lizel. Relevance of the cancers and wood rot patterns on stone fruit trees. Luister graag.
Dankie Pietro, ek het eintlik gehoop jy los die laaste sin en toe begin jy met die laaste sin. Right, good afternoon. I'm really glad to speak here at the Hortgro Technical Symposium. I'm just going to lower this a little bit, just see if I got this one right. So today I would like to talk on cankers and root rot pathogens, on propagation material in nursery trees. And I would like to acknowledge the people that have worked with me on this. Rona van der Merwe was an MSc student. Vernon Jacobs, he did an honours study on it. And Francois Halien is my collaborator at the Infratech Nitverbij at the ARC. So all of them have contributed to this work, and I would like to acknowledge them. So in my talk, I will firstly want to give you an overview of stone fruit trees that has been analysed by our plant disease clinic. We've got a commercial unit within our department. Well, it's moving to becoming commercial, but they provide a service to the industry, as many of you would know. Then, moving from there, I would like to look at the project that was initiated by Hortgro, looking at propagation material and also nursery trees. And then lastly, how does all of this information play into management practices? So let's start with the trees that was received by the plant disease clinic, and we're looking here at a period of 15 years. So over 15 years, 210 stone fruit trees have been received by the disease clinic, and this is specifically for above ground problems. So not below ground, not soil-borne. And there you see a breakdown of the trees. Plum was definitely in the highest, 39% of trees received, then peach, and then nectarine. If we look at who's done it, who was the pathogens associated with the symptoms of diseased trees that were received, here is a graph showing you all of the diversity. I would just like to point out that the Botrys of which Diplodia seriata was the main contributor, and then Leucostoma and Diaportae. So I'm not going to bore you with all the names. The question that I would like to ask is, what is the economic impact of those trees? Of the 210, I would say they represent 200 orchards. So one or maybe two trees are sent in for analysis, but how much of the rest of that block is affected? How much of that would have been removed? And how would it have influenced production? So making a sum, doing the calculation of the economic impact is something that I would really like to achieve. And it's something that we've mentioned at the beginning of the year at the Rootstock committee meeting. I've not had time yet, but before the popular publication come out, I would like to really engage with people in the industry that can help me to make such a calculation. So let's get to the project that we did. The plant pathology part, and Hortgro initiated a project on apple trees, which I've already given feedback at a symposium. And then after that, we looked at the stone fruit nursery processes, looking at both the propagation material and also the nursery trees. And our question was, what is the phytosanitary status of these two plant material types? And whatever we isolate from there, what is their pathological relevance? So looking at Scion material for the propagation material, we looked at both green Scion shoots and also dormant Scion shoots. And there we looked at 9 different Scion and also 3 plum Scion, green Scion shoots. Let me see, what is the... Yeah, and 3 plum cultivars for the dormant Scion shoots. So what we did there was isolate or cut off the buds, as you would do for oculation, 8 buds per shoot. We put it on a medium, and we see whatever grows out of here. Something that you need to take account is that we used material that were visually clean, so they were not visually diseased. So for rootstock material, we took dormant rootstock shoots, 180 shoots per cultivar, 3 plum cultivars, one used for nectarines. We made sections from these dormant shoots, and we plated the material also on media and looked at the fungi growing from there. Then we also looked at ungrafted rooted rootstock plants, 120 plants per cultivar, 3 plum cultivars, and 2 cultivars used for nectarines. Here we isolated from the tip, the browning that we found from there, from the crown, the middle photo, and then from any wounds that we would find on these plants. So from this material, what did we find? From the green Scion buds, only 0.4% of 3,840 buds were infected. From the dormant Scion buds, a bit more, 1.2% out of 2,880 buds that we analyzed. The main pathogen was Cornishita pronicula for the green Scion buds, and Trincatella angustata for the dormant Scion buds. Interestingly, of the disease clinic trees that has been analyzed, Trincatella have been associated with a diseased tree. It's not a common pathogen, but we have found it. So from this, we see that the dormant Scion buds definitely have a higher occurrence of canker pathogens occurring on them, most probably because they've got a longer time of exposure to aerial inoculum. Let's look at the rootstock material. Of the dormant rootstock shoots, 6.2% of the shoots had canker pathogens, and the major pathogen there was Cytospora leucostoma, an important pathogen for the stone fruit industry. Ungrafted rooted rootstock plants, 378 plants, approximately 11% of these plants had infections with canker and wood rot pathogens, and 6.4% with Cylindrocarpon-like fungi. The main pathogen we identified there was Cadathra luteolivacea. So the dormant shoots from mother trees was already infected, and most infections were observed from the crown of ungrafted rooted rootstock plants. And we'll come back to that area of infection when we look at the nursery trees. So next we moved on to the nursery trees. We sourced nursery trees from 3 different nurseries. And here it was 9 combinations of Scion and rootstock cultivars, and then 2 of 1 nectarine with 2 rootstock cultivar combinations. So this is just a very simple illustration of a nursery tree. It's not a potted nursery tree, as we know that is not usually the case currently in the industry. So we did isolations from different areas of this nursery tree, from the rootstock wound, the bud union, and the crown. So what did we see when we split open these trees? On the left-hand side, you can see the streaking from the crown. That's really important. And this is a symptom which Becker Wessels actually alluded to me already about 10 years ago, saying that there's something in the stone fruit nursery trees that he doesn't understand. And this is this brown discoloration from the crown of the nursery trees. That plant there in the middle is of the seedling Carcamas. So it's not an open wound rootstock. And that clearly shows you how clean the base is of that rootstock. That would be similar to a tissue culture plant. Then some other discoloration that we also find is the bud union. So what should a good bud union look like? There usually is a thin line where the bud was attached, but there should be no brown streaking. And then from where the rootstock was cut back, there's also a natural die-off that happens there, but that die-off should not be a brown streaking running into the vascular tissue. So from a total of 1,080 trees, what did we find? Out of 22% of them, they were infected with canker and wood rot pathogens, and 24% had Cylindrocarpon-like fungi. So for the canker and wood rot pathogens, we did not find any significant differences between the cultivar combinations that we looked at. However, for the soil-borne fungi, the Cylindrocarpon-like fungi, we did find rootstock differences. So the rootstocks are coded there at the bottom, but what I would like to point out is that the rootstocks that had the highest infection with the Cylindrocarpon is the number 1, and that is Maridon. And in contrast with Piet Stassen says Mariana is more susceptible than Maridon, but what we found here is that Maridon is quite susceptible for Cylindrocarpon. And then, just lastly, the rootstock with the least infection is again our seedling rootstock, the nectarine 1-2. When you look at the different plant parts that was infected, with the canker and root rot pathogens, there's a significant difference between the infection in the crown and in the wound. But all 3 plant parts was infected, and those percentages in terms of producing clean trees is significant, from 6 to 11% infection. If we look at the Cylindrocarpon-like fungi, they occur in the soil. They are soil-borne. So where did we find them? We found them mostly in the crown area. So this pie chart gives us a breakdown of the major groups that we identified. The Cylindrocarpon-like fungi, Cadaphra species, Botrytis Amphispheriaceae, and then 21% of other species. I would like to point out the wood-rotting fungi was actually quite low, 1.4% in total, in contrast with the apple nursery tree results that we obtained. So if you look at the major fungal groups, canker groups, where were they found? On the plant itself. With Cadaphra, it was mostly from the crown. So, and that is also an interesting finding, that Cadaphra infects from the soil, being then also soil-borne. That's where the infections came from. For the Botrytis, the highest infection was in the bud union. So either it comes from the bud or during the budding process. And that is also 2 areas where control will definitely be needed. We did a very small investigation in comparing plants that were produced by tissue culture, the rootstock produced by tissue culture, versus a plant that was produced by a hardwood rootstock. It was only 40 plants, 20 of each. And from these plants, we did isolations, as in a similar way with the nursery plants. So I would just like to indicate what we isolated from the different areas. The tissue culture plant was planted out again in the open field and oculated in the open field. So it had exposure in an open field situation. So this summarized the pathogens that was isolated from these 2 plants. And what I would like to, I think it's purely coincidence that the hardwood plant, the wound had no infection, but all of those highlighted in yellow are the Cylindrocarpon-like fungi. And what we see here is that the hardwood plant definitely have got a higher number and also diversity of the Cylindrocarpon-like fungi associated with it. So I'll come back to it in my summary, and my recommendations is that producing rootstocks via tissue culture definitely will hold an advantage for preventing Cylindrocarpon-like fungi infections and also other soil-borne fungi. So that's what we have. Now we would like to see what does it mean? What are their pathogen status? We got quite a high diversity of canker pathogens. Are all of them important? So we went and we first inoculated the canker pathogens on 2 plum orchards on 2 to 3 year old wood. We made a wound with a plug, and we put with a cork borer, and we put a mycelial plug in, and then we measured the lesions after 4 months. So as you can see there in the bottom, that was one of the Lacidiplodia that actually formed quite a long lesion after 4 months. So this graph has got, it looks like a barcode that you would find on something that you actually go and shop, but it's the list of all the isolates that we inoculated. There are 2 isolates per species, and what I would like to highlight here is that is the control with only a wound. There is some wound response that we do find, but all of the species that we inoculated formed lesions that are significantly longer than the negative control. Lacetoplodia was the most virulent, as you can see there, forming quite long lesions. And we also had a typical response like that on our second orchard. So Lacetoploma theobromei, how important is that for the industry? It's the first report for stone fruit in South Africa, although the pathogen is known to be present in South Africa. But it is known to cause cankers on almonds in California, dieback on nectarines in Turkey, and gummosis on peaches in China. A species that was the second runner-up in terms of virulence was Biscognosia, that causes charcoal canker of oak. So what we found is that the species that we have, the Mediterranea, is pathogenic to plum. But its occurrence is very seldom. It's not a pathogen that occurs widely. So what about the Cylindrocarpon-like fungi? What would we say of them? Are they important or not? So we did 2 different experiments to determine their pathogenicity. The one was by inoculating detached shoots of 2 rootstock cultivars, Maridon and Mariana. Here again, doing a plug inoculation on the shoot and then leaving it in water that we refreshed every week for a 7-week period. And after that time, we split the shoot and we measure the lesion that was formed. So this is on Maridon. The list of the species are there at the bottom. They formed lesions that were significantly larger than the negative control, and Ilulectra lirudendri was one that definitely stood out in this case. Maridon, and this is the results of Mariana. Then we wanted to know, what if we used whole plants with roots and we exposed them to these fungi? What would the effect be? So we had an experiment where we used tissue culture-produced rootstock, GF677 and Atlas, and we used a millet seed inoculation, and we also induced water stress on these plants and had them for a certain period of time in the glasshouse. So we did find some symptoms on these roots that included black sunken lesions, black discoloration of the roots, and also girdling. But overall, unfortunately, we did not get significant differences between the negative control and the treated plants. And the reason for that would mostly be because we need a longer period of time, and that will have to be repeated. But the relevance of Cylindrocarpon is something that we should really take note of and also think about, because these are opportunistic fungi. If a host is stressed, these fungi can cause disease. They're also quite ubiquitous. Cylindrocarpon, we've done a study on grapevine nurseries, and in the nurseries that we investigated, they were present in all of the nursery soils. So they occur really very wide. And we need to understand what are their role, especially in what we call replant. There's a category within the stone fruit diseases which they call replant, and Cylindrocarpon definitely plays a role in that. And a more integrated study looking also at nematodes, looking at Phytophthora, would be necessary to establish the contribution that Cylindrocarpon can play. Right, in summary, stone fruit nursery trees and propagation material can harbor latent infections of canker and wood rot pathogens. So trees that look clean aren't so clean. We need to do something, and what management practices can we advise? So I would like to just allude on a few. For nurseries, we need crown protection, and that is not from the British house. The base of the hardwood cuttings that are pushed into the soil needs to have some protection if that is to be a production way that is still continuing. And there's some research into that needed to find what best antifungal compound can we actually put down there in planting them. Tissue culture rootstock plants is definitely a game changer. I think that is something, if the industry wants to move towards producing clean trees, that is the way to go. Ensuring clean buds, that's also an area where research is needed, where we need to understand what else can we do to produce clean buds, so that or below 2% infection is not, we want to lessen that, especially for the dormant shoots. Budding practices. Your budding knives need to be cleaned on a regular basis because that can definitely carry over pathogen propagills. The rootstock wound that are made on the nursery tree needs to be protected, and you need to use the right pruning wound sealant. And then sanitation. Sanitation is really important. In nurseries, if you have plants that have died, that material needs to be removed from the nursery. It should not lie there in the orchard, because often there is some pathogen in there and it can sporulate when it's just lying there as dead wood in the nursery. So remove all dead wood and shoots. So all those in bold are practices that can be done as of now. Then for both nursery and on farm, because I'm not sure to what extent producers actually store their trees in cold rooms and to what extent. This is a study that was done in California, which I think is very interesting and noteworthy. And that is the effect of cold storage on trees. As you can see there on the photo image, I mean, that's a real MIFS ball. So trees that have been exposed to too cold temperatures, what they note in that paper is that they found ice in the cold store. So the trees obviously were exposed to freezing temperatures and also to long. So the trees dried out. The wood started to desiccate. And then you find that latent infections come out and they are a problem. And they say that in a period from, I think, when was it? 2009 to 2011, they had a lot of problems with trees that died and had to be removed due to cold storage problems. The pathogens that they associated there included Cylindrocarpon and Ilunectria. So predisposing stresses can be minimized by lifting trees from fields prior to hard frosts, maintaining storage temperatures between 0 and 4 degrees, keeping trees well hydrated without excessive water, and transporting trees quickly to the growers' fields after removing from cold storage. That is from the Marek paper. And then I've just got a last recommendation, and that is the planting practices needs to be optimal. Trees that experience stress during planting will definitely exhibit the latent infections, and they will be triggered. We've updated the scheme's recommendations in terms of the pathogen list from what we found in our studies, and also thanks to Rachel Kriel that aided in that, and we hope that will help. The only problem is the scheme look at visually on the outward part of the plant, where you actually need to go and cut open a plant and look on the inside. So I hope that will be taken into account in the revision of the scheme's actions. I think that is really a problem, and I think a solution might be that nurseries themselves have a system where they actually assess how clean their plants are. So you can't manage what you don't measure. I'd like to end off with that saying. Thank you.